So we are now on to question 28, which involves three blocks, block A, block B, and block C, of varying masses. So blocks A, B, and C are aligned along a straight line on a horizontal frictionless surface. The masses of the blocks are m, 2m, and 3m, respectively. Block A is initially moving to the right along the same line at a speed v, as shown in the figure above. Blocks B and C are initially at rest. Block A collides with and sticks to block B. The two blocks then collide with and stick to block C. What is the speed of block C after the collisions? So since the blocks are sliding along a frictionless surface, we know that there is no energy gained or lost in the system, so it is an isolated system. What that means is that momentum must be conserved. So we can go ahead and once again use conservation of momentum to solve this. So if we have block A moving to the right with a mass of m and a velocity of v, and it collides and sticks to block B, the collective momentum of those two blocks with their collective mass must be equal to the initial momentum before the collision. So mv equals the total mass of those two blocks. So since block B weighs 2m and block A weighs 1m, that would add together to 3m. And then since we have multiplied the mass by 3 and we need the momentum to be conserved, that means that the velocity needs to be divided by 3. So we have mv, our initial momentum, right there. And then as soon as it collides, it becomes 3m, and the velocity becomes v over 3. So then the second collision happens, and once again the momentum must be conserved. So what we're going to have is the collective mass of every single one of the three blocks. So since block A has a mass of m, block B has a mass of 2m, block C has a mass of 3m, that all adds up to a total mass of 6m. And if we have a mass of 6 times the initial mass, and we need this mass times the new velocity to equal the initial mass times the initial velocity, since we've multiplied the initial mass by 6 to get this mass, we're going to have to divide the initial velocity by 6 to maintain conservation of momentum. So after this second collision between the mass of block A and block B colliding with block C, we will have a momentum of 6m times v over 6. So when the question asks, what is the speed of block C after the collisions, the answer is b over 6, because the mass is multiplied by 6 over the course of the two collisions, meaning to conserve momentum, the velocity has to be 1/6 the velocity of the initial velocity.